So in 2015, there was a genetic study that showed that haplogroup E was actually an East African DNA, which, by the way, is strange considering the fact that you find it in Natufians and you find it in small chunks in Europe and you find versions of it in Africa all over the place. So the question is, where did it come from? Well, according to the study, the most likely place is East Africa, and then it was distributed to South Africa during the pastoralistic times, and it was distributed to other places around Africa, and it was distributed to the Middle East. And from the Middle East, through pastoralism, through farming, it was distributed into Europe, which means it's a second out of Africa migration that spilled a little bit but didn't affect everybody outside of Africa, and it didn't affect everybody inside of Africa. Now, if we read the abstract, it says haplogroup E, defined as the mutation M40, is the most common human Y chromosome clade within Africa. To increase the level of resolution of haplogroup E, we disclose the phylogenetic relationship among 7 to 9 mutations found in haplogroup DEY chromosome sequenced at high coverage. In previous studies, additionally, we dissected the EM35 subclade by genotyping 62 informative markers in 5,222 samples from 118 worldwide populations. The phylogeny of haplogroup E showed novel features compared with the previous topology, including a new basal dichotomy within haplogroup EM35. We resolved all the previously known polytomies and assigned all the EM35 chromosomes to 5 new different clades, all belonging to a newly identified haplogroup EV1515, which accounts for almost half of the EM35 chromosomes from the Horn of Africa. Moreover, using a Bayesian phylogeographic analysis and a single nucleotide polymorphism based approach, we localized and dated the origin of this new lineage in the northern part of the Horn about 12,000 years ago. Time frames, phylogenetic structuring, and sociogeographic distribution of EV1515 and its subclade are consistent with a multi-step demic spread of pastoralism, subsequent diffusion to sub-equatorial areas. In addition, our result increased the discriminative power of the EM35 haplogroup for use in forensic genetics through the identification of new ancestry informative markers. For those of you wondering what the hell any of this means, it means that there were some groups before which were previously in their own group, and they were in Africa, and they were considered V instead of E, and they were basically put in the wrong group because they didn't know that they had similarities with haplogroup E. And when they found this haplogroup E, they realized that Africa has a lot of haplogroup E's, and the diversity of haplogroup E is more prevalent within Africa than without. And therefore, the conclusion of this study says that the haplogroup E left Africa in pastoralistic times, right, in that 10,000 space, rather than it being people from the Levant coming into Africa. This is a study that has been shown around by a lot of people, and it shows how difficult analyzing DNA from the Middle East and Africa are, especially when you consider the fact that it might be a back and forth movement within both continents. As humans, we want a clean breakthrough. We want everything to go the way we want it to go, but that's not how the world works. So in the genotyping of the study, we see that there was overall 5,222 samples, and they had markers M40, M20, E. Haplogroup E was defined by EM215, M35, M35, hierarchical genetic, EM40, and it's a variance which used to be V, but then they've been put in this one, and all of these were basically put into the group because of their closeness to E, haplogroup E, and they've been shown to have derived from this group. So basically, they go into their map and they talk about ancestors and correspondence, and the fact that they use six geographies, which are Western Africa, Southern Africa, Eastern Africa, Northern Africa, Europe, and the rest of the world to compare this DNA. And so, they see some things. So in the study, they supplement data reported by Gomes from Uganda and populations in Tanzania. In both the studies, marker M35, M293 have been analyzed for the population from Uganda. We inferred the frequency EV1515 subhaplogroup among chromosomes classified as EM35 through YSTR. For the 7 populations from Tanzania, we approximated 20 the frequency of EV1515 subhaplogroup other than EM293 based on paragroup EM35. Okay, so let's talk about the new information that they found. They found that in their sample set, they found 3 individuals from Eastern Africa that were derived from mutation M40, which defined haplogroup E and ancestral for both P147 and M75 mutations, which in turn defined the 2 deepest haplogroup subclades. We tested these E chromosomes for all their 13 mutations of branch 3, and for the mutations of branch 4. Chromosomes were derived both from the mutation defining haplogroup E and for V3725, but ancestral for V1844 and V1865. We found that these chromosomes also share a new mutation for V44 ancestral in other haplogroup E chromosomes that we identified by Sanger sequencing. Haplogroup EV44 thus represents a new deep branch of haplogroup E, sister to EP147. By this analysis, we recognize V3725 and M75 as the 2 mutations defining the deepest bifurcation within haplogroup E. And remember, this was done from those African places. This is why they believe that it's of Africa. And then you have the phylogeography of haplogroup E. So the phylogeography of haplogroup E. Okay, so this is what it says. By using both the phylogenetic information and the geographic distribution of haplogroup E clades, we performed a discrete phylogeographic analysis to associate each node of the tree to one or more of 6 broad geographic regions with an emphasis of the African continent. This analysis suggests a sub-Saharan placement for MRCA of the haplogroup E chromosome within clade. The posterior probability strongly favors an Eastern African placement for the origin of EM215 diversity, as previously suggested by Semino and Gebremenskel and Ibrahim, whereas a northern African location is favored for the node defining the M78 subclade, supporting the previous hypothesis of Cruciana. Despite we assigned most previous deep EM35 Eastern African clades to a single haplogroup EV1515. Our phylogeographic analysis slightly favors Eastern African origin for EM35. Posterior probability. We found new clade defined by V1515 mutation, which originated and differentiated in Eastern Africa and expanded southward in recent times as a single terminal clade. EM293, a posterior probability of support of Western African origin for haplogroup M2. Within this haplogroup, a shift in location assignment from Western Africa to Eastern Africa was observed, along with lineage leading to cluster of 3 former EU209 samples defined by V2580 mutations. So here's the conclusion that we've all been waiting for. The haplogroup E phylogeny here presented shows some relevant changes compared to with the most updated and complete Y chromosome phylogenies, in which the two deepest subclades were defined by P and M mutations. In this study, we refined the deepest haplogroup E dichotomy, which now involves EM75 and EV3725 lineages, with the P147 mutation defining a branch sister to the newly discovered EV44 lineage. The new mutation V44 and V3725 are eligible markers to test chromosome, which resulted to belong to paragroup E. In other studies, this paragroup, although very rare, being reported so far in 2 Saudi Arabian samples and 1 Southern Bantu, is of crucial relevance for geographic inferences about the origin of haplogroup E and linked hypotheses about movements out of and back to Africa. Keeping these caveats in mind, our phylogeographic analysis based on thousands of samples worldwide suggests that the radiation of haplogroup E started about 58,000 years ago, somewhere in sub-Saharan Africa, with a higher posterity probability for an Eastern African origin. Moreover, it seems that the next 5 major dichotomies also occurred in Eastern Africa. Posterior probabilities ranging 0.84097 in a time frame of about 15,000 years, underlying the importance of this region for the early differentiation of this widespread haplogroup and for the peopling of the entire continent of Africa. One of the most interesting findings of our phylogeographic refinement is the identification of new clade EV1515, which originated about 12,000 years in Eastern Africa, where it is currently mainly distributed. This clade includes all the sub-Saharan chromosome belonging to the former paragroup EM35. We observe the highest frequency and diversity of this haplogroup in northern part of the Horn of Africa, where the majority of the deepest E. In the southern part of the Horn, Haplogroup EV15 is almost exclusively represented by a recent 3.5 thousand years ago subhaplogroup EV148 further south in southern Kenya, in southern Africa, a single EV1486 terminal clade known as EM293 was found. This phylogeographic pattern is strongly suggestive of human movement from northern part of Horn to Ethiopian Kenya borders between 12,000 years ago. Coalescence of EV1515 and 3,500. The coalescence of EV1486, and from here towards southern Africa across the equatorial belt in more recent times. Haplogroup EM293 has been previously hypothesized to mark a recent gene flow through the Tanzania to South Africa as a consequence of a migration of non-Bantu speakers, pastoralists. Our data on the distribution of the phylogeny of the EV1515 haplogroup supports and extends this hypothesis. We propose that the migration marked by EM293 haplogroup could be the final step of a north to south range expansion linked to different branches of EV1515, which initially involved people from Eritrea. This migratory route is consonant in time and space with archaeological evidence for early domestication of cattle in northeastern Africa about 10,000 years ago. Southward climate-driven movement of herders into southern Ethiopia highlands and Turkana Basin around 4,000 years ago, and subsequent equatorial pastoralists expansion towards southern Kenya, Tanzania, southern Africa, not before 3,000 years ago. Within haplogroup EV1515, we also remarked a striking parallel in the geographic distribution of MSY sister clades with respect to mutations found within the enhancer autosomal LCT gene. Both C and G have been associated with lactis persistence in adulthood, and similarly to MSY mutation, are essentially Eastern African specific, recent, and found at high frequencies among pastoralist groups. Similarly to a C14010 EV148 is found at high frequencies in pastoralist population from Kenya and Tanzania, where EV1700 mirrors the distribution of a lactis mutation G13907, being observed at its highest frequency among Cushitic populations of the Horn. Considering the spatial temporal congruencies with other pieces of evidence coming from archaeological as well as genetic, we propose that the observed phylogeographic trajectories of haplogroup EV1515 could be the consequence of multi-step southward movement of early pastoralists from a northeastern African motherland across the equatorial belt. So we went through that to say this. The haplogroups found in Morocco in the Ibermerusians and the haplogroup of Ibermerusians found outside of Africa belong to EM78, 15,000 to 13,000 years ago, or 15,000 BC to 13,000 BC, And I can tell you that this haplogroup is now concluded to be from East Africa, or at least highly proposed to be from East Africa, as you can see. And with this conclusion, it seems like that DNA that people thought came from mixing between Middle Easterners and Africans is actually just a 100% African DNA.